and welcome everyone. So in today's session, we are going to learn some new concepts of our coding. For that, we have introduced a new kind of your sensor, that is your ultrasonic sensor. So I think you have heard the name ultrasound, ultrasonic previously. Now what are these? Actually, these are the sensor that works on your sound waves. So here we have this ultrasonic sensor that works on ultrasound region or ultrasonic regions. Now what is a sound? I think you have already heard the name sound before. So what is a sound? A sound is a kind of energy, or we can call it as it is a disturbance in a wave, or we can call it as a vibration which can travel through certain mediums like your solid, air, water. So these are the certain mediums by that a sound or a wave can travel, and we call those waves as your sound. Now here we have the ultrasonic sensor which will transmit the ultrasonic sound, and it will also receive those sound. So here if you see that we have two identical pieces, or this two sections which is identical. So one is for transmitting the ultrasonic sound and the another one is to receive those sound, and on the basis of that what will happen, we can easily calculate the distance. Now for measuring the distance we have a formula, that is your speed equals to distance upon time. So by this formula we can easily measure the distance if we have the speed as well as the time. So for speed, we have the speed of our ultrasonic sensor, that is for air it is 343 meter per second, the speed of your ultrasonic waves in your air actually. Now in a different medium it might be different, like for water it might be different, or for solid surfaces it can be different, but for air we are measuring it. For current purpose we are going to use the air, that's why we need 340 meter per second. So we have the speed. Now let's see what is the time, or how we can calculate the time. Now here what will happen, this transmitter will transmit your ultrasonic waves, and after striking from a surface or from an object it will get reflected back, and the reflected back waves can be received by the receiver. So here if you look at closely on your side, you will see that we have a T and a R written over there. T stand for your transmitter, R stand for your receiver. So T will transmit the ultrasonic wave which will received by the receiver. Now let's take an assumption that from here we are transmitting the ultrasonic waves, and this is an object which is placed at a certain distance. We know the speed of it. Now from here the ultrasonic waves is transmitting, and it is strike back by this object and received by this receiver. Now the time taken here, you can see that it is twice, going from A to B and from B to A. So this is a twice actually. So what we can do, we can divide whole of the thing by 2 so that we get an exact value, that is from A to B. So for that actually we have already included all this in a library. So this is the internal your steps that we done when we don't include any kind of library. But for now what we are going to do, we are going to our Sketch programming, and in that we are going to include the sonar sensor, and in that sensor actually all these codes or all these mathematical calculation has been done already over there. So we don't need to do those kinds of calculation. So let's see how we can do that. So you have to open your Arduino Sketch file, and after opening the Sketch file, just click on the Sketch to include the library. So here click on the Sketch file, and here let's include it. So click on the include library section, and here search for your modular. So if I scroll down, I can see a modular option there. Just click on it. It will include the necessary libraries or the header files that we need for our this code to run, or it will has all the necessary details for it. Now what we want to do, I want to include this as we have included rest of them, like your RGB, buzzer, your proximity sensor, all of them. So what we have to do, we have to begin it, or first of all before beginning it we have to create an object for it. So let's create an object. So write modular, give a space, write the name of your object, that is my bot. For my case, you can write any name over here. You can write your name also. So this is the object name. By that we called it. So I am calling it by the name that is my bot. Now after that, let's go to your setup file. Now in setup file, we write the code that will execute only once. That is the initialization. For example, I am initializing this ultrasonic sensor. I am initializing this RGB. So like that, what are the your objects that you initialize or you want to run once? You have to write the code over in setup. So right now I will initialize two things. That is the sonar sensor as well as your serial monitor, so that I can see the output of it. So as I told you, it will measure the distance. So whatever the value of the distance that is giving in me, that is the response or the feedback, I want to see it, that whether it is 1 centimeter, it is 1 meter, 100 centimeter, or whatever XYZ the value is, I want to observe it or to see it so that I can use those value in my project. So for that I need a separate window, that is your serial monitor, and in that we are gonna view it. So let's write the code for opening it. For that, what you have to do, first you have to write the name of your object, that is my bot dot. Now we have to write the command for it, that is USB begin, and inside the parenthesis we have to write the baud rate. Now baud rate are the your rate or are the values, or we can call them the frequency under which our laptop or this PC and the controller will communicate. Now here I am writing 9600. This is the baud rate by which our controller and the PC will communicate. Now after that I have to initiate this sonar sensor also. So you have to write my bot dot sonar begin for initializing them, and inside of it I have to write in which port I can connect it. So for that, let's refer to our that sheet in which we have all the necessary functions, all the necessary command that we are going to use according to your blocks. So if I open the sheet here, if you see, this is the our block, that is a sonar sensor, and for sonar sensor the function name that we can use is sonar begin for initializing it, sonar read for reading the value from it, and apart from that the parameters, that is your port number that we can use is 1 2 3 4. So I can use any one of the port in these four. So we have port 1, port 2, port 3 and port 4. Out of these four I can use any one of them. So for me, let's connect it to port number 3. You can use any different one also. So let's say I connect a snap wire over here and the another one over my this port number 2. Okay, and after that what we have to do, we have to let's go to our code again, and here we have to write the 2. That is a port number that we are giving to it, that we have connected. Now this is it for the setup file. Now after that we have to go to the loop, and in the loop I have to fetch those value using your sonar read function. So for that, let's write or let's create a variable that will store those value. So let's write int. We are creating the variable as an integer type, so that because we are saving them as your numbers, that is your digit 1 2 3 4 like that. If those are character, we will use a character type data type. If these are in strings like a name, then we can save them as your string data type. Currently we are going to use the integer because I know the final output that I will get, that is will be a number, because that is a distance, and this for measuring the distance we use the digits, that is your numbers. So here integer, and here we have to write the name of the your variable. So let's say the name of variable is distance. Now we have to read those value. For that we have the function name as sonar read my bot dot sonar read. Inside of that we have to write the name of the port, that is 2. From 2 we are gonna read it, and after reading it I also wanna see it, because I want like if I don't see it I cannot understand what is the value that we are getting it. So for that we have to use this serial monitor actually. Okay, over here. So let's write the code. MyBot dot USB print, and after that I have to write int because we are getting the value as your integer. And after that, let's write the port from which we are getting, or here we have to write the name of the value that we want to see. We want to see the distance actually. So let's copy it and paste it over here, distance, and after that put a 1 also. 1 stands for your new line. So if I don't write 1, then all the numbers that you will see, that will be on a same line. Okay, now after that, let's provide some delay. Let's say of 200 millisecond, and let's upload the code. It might ask you to save it. Let's save it. So for me it is reverse parking. So actually reverse parking is the name of the project that we are gonna do over here. So let's see. You can see that we have an error over here because we haven't connected to our laptop. So let's connect to it. And after connecting to it, let's again upload the code. So for that, let's go to your tools, and here tools, we have the serial monitor over here, and the shortcut for that you can see over here, that is Control Shift M. And apart from that, we have this option over here also, that is of serial monitor. So let's click on it. Here you can see that serial monitor has turned on. It is showing some values, and apart from that, here you can see the baud rate, that is 9600. Now here it is showing the value, that is 16, 15 or 10. Let's see, remove my hand. Okay, actually it is showing like this. Now if you see the value, it is 164, 165, fluctuating between them. When I make or move, like take my hand in front of it, you can see that the value distance has decreased. It is around 21, 22. Okay, when I move it closer, it is reducing. The value of your sensor is reducing, and as I move backside, the value of the sensor is increasing. Okay, so this sensor can be easily used to calculate the distance between your two objects. The first one over here and the second one that you want to measure, you can place it in front of it. So for example, I want to measure the length of this wire. So let's say I put it over here and another end over here, and take my hand. So it is around your 16 centimeter, the value length of this wire. Okay, so like that you can easily measure them. Apart from that, as you know, the project that we are going to do over here, that is your reverse parking system. So what is your reverse parking system, or what will happen in reverse parking system? So actually we are going to use this RGB LED to get an alert. So when we park the car, we can use these kinds of your sensor, that is your ultrasonic sensor, so that they can give us an alert that it can be touched to the touching to any kind of object, or we have some distance there or not, that we can park our car or not over there. So for that we can use it, and here we have the RGB LED that will use as an alert system. So what we can do, we can generate this 3 color over there. That is, on the first, let's say if the distance is less than 20, what we are going to do, we are going to turn the blue color LED, and if it is less than your 15, we are going to turn the green color, and if it is less than your 5 or 10 centimeter, let's say 10, what will happen, the red color LED will glow, so that we can get a warning that if the red color LED glows, means we are too close to the object. So let's see how we can do that. So for that, let's close this serial monitor, and now we have to use a conditional operation, and we have to include this our RGB LED. So first let's include the RGB LED. So for that, let's go to setup. Here we have to write MyBot dot the name of this, that is your RGB begin, RGB begin, and here let's I'm going to connect it port number 3. So let's write 3 over here. So we have initializes our LED. So in the setup, we write the code that we want to begin, or we want to start or initialize them. So here you can see we have initialized these 3 options, that is USB begin, sonar begin, and RGB begin. So we have your serial monitor, sonar sensor, your RGB LED. Now apart from that, let's say here Let me delete this delay for now. Now here let's add a conditional operation, that is your if else condition, that if certain task has been completed, we have to do this. If the task doesn't complete, or like if another task completes, then we have to do this. So this is your conditional operation, that if certain task is fulfilled, we have to do certain kinds of activities. Let's write if, and inside the if, that is a parenthesis, we have to write the condition that needs to be fulfilled, and inside this curly braces we have to write those values that will be executed. That for example, after completion of this logic, this action should be completed. So let's say if the value of your distance is less than your 10 centimeter, then what should happen? I have to turn on this RGB LED. Now here in the RGB LED, we also have two kinds of RGB, that is a common cathode and common anode. So here with me I have, that is your common cathode, so I have to also include it. So put a comma and write CA for common cathode. Okay. After that, here we have to write the code to turn it on, that is mybot.rgb, oops, it is dot RGB set red, and inside the parenthesis we have to write the port, that is 3, and the value, that is 1. 1 means your high and to turn on, and the rest of them should be low. So let's copy it and paste it. The rest of them will be your green and blue. And then this should be off, so we have to make them 0. Okay, let's check this much for now. So let's upload the code and let's connect the snap wire to our port number 3. Over here, let's also turn on the serial monitor by using the shortcut Ctrl+Shift+M. Now the distance is very much high, that is your 160. Let's say it's 26 or 27. Take it closer. So we have to make the threshold as your 10. So let me take it more closer. Here you can see, as it turns to 9, which is less than your 10, the LED turns on, and after that it is not turning off because we haven't written the code for it, that what should happen once it turns on, that if the value again goes greater, then we haven't write the code for it. So let's write the code for it once again. So here after the if, let's write an else condition. In the else, we have to turn off all of them, that is red, green or blue. Okay. Now if I upload the code now, you can see that the LED will again turn off. So let me also turn on the serial monitor. See the distance. Let me make it closer. It has turned on. When I take my hand far, it is turn off, turn on, turn off. Here you can see. Let me make it over here so that you can easily see it. Now what we can do, we can do a similar thing for your green and the blue. So let me do that also. Let me turn it off. So here we are going to use another option, that is your else if. So first of all, our code will check that if this condition is fulfilling or not. If this is not fulfilling, means the value distance is greater than your 10, then what should happen? It should check the else if condition. So let's copy the code, paste it over here. Same with this one. And here let's write 15. Let me turn on the green. And let's write the code one more time. And here for your blue, let's upload it and let's see how will they work. So as the code has uploaded, so let's also turn on the serial monitor. So value is pretty much high, that is 160. Now let me take my hand closer to it. Okay, as you can see, at the value is less than 20, your blue LED has been turned on, and when it is less than your 15, the green LED will turn on, and when it is close, the red LED will turn on for warning. So if the LED is like your green will turn on, I have some more distance that I can take my car backside. Okay, and if the blue is there, means I can easily take my car backside, and if there is no LED, then there is no obstacle over there. I can easily make my car to park at the place because the object is not near to it. So this is how you can easily create a reverse parking system. Apart from that, you have learned the logic of how the ultrasonic sensor works, how to measure value from it, how to control it using your if-else condition, and some of your science behind it, that how the sounds work, how they are travel. So this is all about how you can create the reverse parking system using your ultrasonic sensor and your RGB LED. So similarly, in our upcoming session, we are going to create more interesting projects like this. So see you in the next session.